Everyone, we will solve this today's LeetCode problem. So it's a LeetCode medium one. The question is walking robot simulation. Let's see what the question is asking. So basically, a robot is on an infinite xy plane. It starts at point 0, comma 0 facing north. The robot can receive a sequence of these three possible types of commands. The -2 is for left turn, -1 is for right turn, and a k move forward k units, 1 unit at a time. If there is no negative number, then if it is a positive number, then we need to move forward that k unit of times, right? So some of the grid sequence are obstacles. The ith obstacle is at grid point obstacle I, and xy. If the robot turns into an obstacle, then it will instead stay in its current location and move on to the next command. Return the maximum Euclidean distance that the robot ever gets from the origin squared. That is, the distance is 5, return 25. So basically we have given some directions, right? Some commands to move left and right, right? Some commands to move left or right, or a k value, k positive value, to move k unit of time, k unit of time, k unit of steps in that particular direction, right? Right. So basically, and we have also given some obstacles, right? We have given some obstacles, the coordinates, right? The coordinates has some optical, the coordinates which is given some obstacles, that if the robo can moves to this coordinates, reach to this coordinate, then it will stay in that current location. It means not on obstacle point, but just before it point, right? That it will, instead of moving to that obstacle, it will stay there and then wait for the next command, right? That's what it is saying, that instead stay in that current location and move on to the next command. So it will not move to the obstacles, but it will, just before the obstacles it will stay, and it will wait for the next command to move left or right, right? That's what the meaning of this. And we need to find the maximum Euclidean distance. So what is Euclidean distance? So it is the distance between, from the origin is squared, right? It means it will just like x minus 0 ka square plus y minus 0 ka square, right? This is the Euclidean distance, right? So if you see here in this, that if it is a Euclidean distance, so if it's a Euclidean distance, it would be the square of x square plus y square, and that would be the max distance of between them, right? So that's what the we need to find here, right? So basically, if we see the first example, the commands and obstacles, no, take the second example. Here it is given obstacles also, right? So if we take the second example, you see that the first direction is north, right? Let's make a direction which is a north, right? So I am at north. So when the first command is 4, it means it's a positive, right? It's a positive command. So it will be, it's a positive command. So it will be move in that north direction also. So it will move to till from 0 comma 0 to till 0 comma 4 in the north direction, in north direction, right? Now the next command is -1, and here -1 and -2 is given us to left, right, and right directions. So if -1 is given, we need to move right. So when we move to north and we turn to right, which direction will come? East direction, right? So from 0 comma 4 it moves to east direction, right? So now direction is changed to east direction, and next command is 4. It means I need to move 4 units in each direction. So when I start moving at a time, so it will move to 1 comma 4. Then when it try to move 2 comma 4, we have an obstacle at 2 comma 4. And what we need to do when we got an obstacle, we, instead of moving, we stay in current location. And what the current location, which is 1 comma 4. So we will stay in here and wait for the next command, either left or right, instead of this positive numbers, right? So we will stay in this 1 comma 4 in each direction and wait for the next command. So next command is -2, right? And -2 is for left. It means when we got -2 and we turned left, we again move to the north direction when we turn left from east. So now the 1 comma 4, the robo is now turned to north direction, and when we got another command which is a 4, it means I need to further move in the north direction by 4 steps, right? So from 1 comma 4 we will move to 1 comma 8, right, in north direction itself. And now commands, we have completed our commands. So direction is 1 comma 8. So basically now we need to find the maximum distance from 0 comma 0 to each of the directions, which is like 0 4, 1 comma 4, 1 comma 8, or in between this 1 comma 5, 1 comma 6. It can be also possible that in between it is a maximum distance, right? So we need to check for each and every coordinates this square part, right, and store the maximum distance between them, right? So basically we need to check for each coordinate this x square plus y square, and which will be the maximum and which will be the maximum that distance will be our answer, right? Now now the question is how we will move, how we will get the commands and how we will move. It's totally on your implementation, that how will you uh, move in north, east, west, or south direction, right, on getting this command, right? So basically what I will do, I will make a 4 directional array, 2D array, right? And I will start moving in, right, like this: north, then east, then south, then west. Why I'm doing that? See, the first is, if you want to move in north, you don't need to move in x direction, you just need to move in y direction. So that would be 0 comma 1, right? When you want to move in east direction, you don't need to move in y direction, you just need to move in x direction. X direction will only change, so that would be 1 0, right? When you want to move in south, it means down the coordinates, you don't need to move in x direction, so that would be 0, but you need to move in down direction, so that would be -1 to move in down. Same for west, -1 and 0, right? Because you are moving in west direction, so -1 for that. So this is the four direction for moving in each direction. After getting this command -2 or -1, we are moving in this, right? NESW, right? Why I have done this NESW, not any other order? You will see, right? So first I am at north, right? When I got a command current, suppose -2, what I will do, I will I am at 0, right? Suppose this I am currently at north, right, facing north. So I have started from k is equals to 0, which is this north pointing, right? So when I got current -2, which is for the command of left, for left. So when I move from north to left, which is west, so west is at fourth position. So what I will do, I will just decrease this by -1 plus 4. What it will give, it will give me 3. Either you can do like this, k minus 1 plus 4, or you can do like this, k plus 3. But when you do this k plus 3, you need to take a modulus of with 4, because this k plus 3 will give you, can go to out of bound this 4. So you need to do this modulus 4 in that condition, right? Either you do this k modulus 4, or you can do this, both is true, right? When current is -2. So see, if you are at north and you want to move in left, so you need to 0 plus 3, which is west. So this is the west direction, right? When you are at west and again move left, so you are in west and you move left, you need to go to the south point, which is at third position. So you are at 3, k is equals to 3, you are at k is equals to 3, which represent west, and you need to move again current -2, so you need to move to south, right? So 3 plus 3, which is 6, and takes a modulus, which is 2. So 0, 1 and 2, you are at south position. Same again, you go to left or right, anything you possible, this will work, right? This will work for left part. When the current is -1, right? The current direction is -1, which is this, and you need to move right. So for moving right, suppose you are at 0, which is representing north, and you need to move right. So where do you would go? You need to go east. And where is east? At after the just north, after just north. So that would be k plus 1. You just need to do this k plus 1, and with modulus, because when you are at west and you move to right, you will face to north, which is after this. And when you do k plus 1, the k will become 4, and that will modulus take 0, right? So that is the implementation, how you implement that, right? That's not an logical one, but yeah, this is the implementation, how you do that. It's totally depends on you. Also, you need to check obstacles for each step, right? So that's how this question will be solved. This is very the question, just like the question is asking, and you do the steps, right? Why it is working? Why? So because k is very low, right? K is at only 1 to 9. If k was bigger, then the question was something else. You need to apply binary search and all, but k is very small, so this can work, right? This can work. So let's just implement this. So first thing is to store obstacles, right? Because we need to know that where are the obstacles. So let's just take this as map. So this map is a coordinate, this map need to store the coordinates. So it will take a map, right, for marking visited, right, this obstacles. So I will store all the obstacles here, all the obstacles. Let's make it obs, right? I will store all the obstacles here. X++. I have stored all the obstacles, and I will because I need to check further for each and every obstacles, right? So I will stored in map, right? Now what I will do, I need to make a 4 directional array, right? So the first is, so what is the order we are following? We are following n e s w, right? So 0 comma 1, 1 comma 0, 0 comma -1, and -1 comma 0. This is the direction we are following. Okay, the first coordinate, starting coordinate is y0 is j0, and the direction is starting is north 0, right? Because starting is north position, so we will start now. For the commands, right? When we receive the commands, so if command is -1, if command is -1, we need to move right, right? We need to move right. So for moving in right, and we are at north, moving in right, it will move to east. So what we need to do, we need to just k plus 1 modulus 4, right? It will tell me that I need to move to, I need to move to east. So that will give me east point, right? When I am at -2, the command is -2, it need to be moved in left part. So left part is north, left is west, which is at the last position. So either you do like this, k plus 3 modulus 4, or you can write like this, k minus 1. But if you do k minus 1, it will lead to negative, so we need to make it positive. So I will just add 4 in this, take modulus 4. Either like you write like this, or you write like this, both is true, right? Else if it is not -1, if it is not -2, so it must be a k, right? It must be a k. So if it is a k, so we need to move k times to the new coordinate, right? And the new coordinate would be what it would be. So we know the direction using this k. We just need to move in the further that direction. So the direction is k, so we will move in, we move to this, and the first will be the x direction, so we will just add it. And the new coordinate y will be y plus direction k plus 1, right? And before finding the maximum Euclidean distance, we need to verify that whether this is an obstacle or not. If it is an obstacle, we don't need to move further, right? We are stuck at there, right? We will not move further, we will stuck in that current location. So for that, we will just check whether this new x and new y is in our obstacles or not, right? That's why we have stored this vector coordinate, right? So if it is, we will break this, we will not move further from here, right? Otherwise, we will just update our new coordinates with the old one, because further we will discuss on this new coordinates, not on previous coordinates. So we will need to update it further, right? So we have updated it. Plus, we also need to find, ultimately we need to find the distance, Euclidean distance. So we will check also here that with we need to find, so this will be the x square, that will be x square plus y square, right? So that's how we will find this maximum. So why I have not written x minus 0? Because x minus 0 is x, so x square plus y square, right? So this is how we will find the maximum distance, and after that, ultimately we will just return our answer, right? That's how we will solve this. Let's just run this. Okay, something is wrong. 7 and 25. Okay. Mm, something. So let's just analyze this. Vector int mpx we have stored successfully. Four directional. So north is 0 comma 1. North is 0 comma 1. Then the way, east is 1 comma 0, right? Correct. Then 0 comma minus 1 and minus 1 comma 0, which is correct. We are going moving from x0, y0 and k0. C is equals to minus 1. So k, if c is equals to minus 1, k plus 1 is 4. C is equals to minus 2, k minus 1 plus 4, modulus 4, which is true. We are moving then C, x direction k0 and count. What is, okay? No, this new x and new y will be true. We have updated this. What is wrong? This is coming 7. Oh, okay. I think this this would not work, right? I think this is not working. This would be like learn square. Why have written x square like this? Yeah, that x squared is something else, right? This should write like this: x into x or plus y into y. X to the power 2 is not will not work in programming. It's work in general scenarios, right? So yeah, this is how we solve this problem. Let's just submit it and verify that we have correctly done. Yeah, we have successfully done. So this is one method, right? This is one method, and we have uses map. So if you want to use, why haven't you uses unordered map? Because unordered map will not work in this case, because we are storing a vector in this, right? We are storing a vector in this. So unordered map is a hash table, right? So it does not work. If you run this, it will give error, right? It will give error that constructor unordered map is an implicit deleted default constructor, right? So that's why we are using map. So if you want to use unordered map, so instead of storing this vector, you can store like this in a string. So for that, you need to make some changes, like string as to string. So convert this coordinates to string, right? So convert this coordinates to string to solve this using unordered map, right? Then you can simply store the string in the map, and you are good to go. Same with here for checking, right? So what you need to do, you need to store this new x, you need to store this new y, and what you will check, you will check just this string as, right? Just this string as, and yeah, you are good to go. The same, then you can use another map. If you want to store use another map, you need to store this as a string. Now you can submit it. It will give the same result and the same time complexity, just nothing changed, right? Nothing. You see 134 ms, it's nothing changed, right? So it totally depends on implementation, how you will use that, right? So basically the time complexity would be, the time complexity would be is, first thing, obstacles. iterate in whole obstacles, then you iterate in whole commands and move in directions. So this is ultimately is 9, right? So 9 into this commands, if you move further again and again, again and again, so 9 into this commands, right? So basically it's just an O of m plus O of maximum of 9 into of m, right? M is the size of obstacles, m is the length of obstacles or size of obstacles, you can obstacle obstacles, and n is the command, right? N is the command, right? So this is ultimately O of m plus n. And the space complexity, so we have taken an unordered map to store the coordinates, right? So that can be O of, again O of m, right? O of m, and ultimately we will find the answer. So this is how we solve this question. Hope you understand it. Thank you so much.